More than 2 centuries ago, in the silent corridors of the Berlin Academy, a young mathematician plotted equations that would echo for generations. Alone in his workroom, by the dim light of a candle, he glimpsed invisible but real worlds. Elliptic curves, integrals, dynamical systems. Few knew that these formulas held keys to understanding everything from the motions of the planets to the secrets of modern physics. This is the universe of Carl Gustav Jacobi, and you are about to enter his brilliant mind.
The Greatest Mathematicians of All Time. Episode 13. Carl Gustav Jacobi. Jacobi was born on December 10, 1804, in Potsdam, Prussia, now Germany, and died on February 18, 1851, in Berlin, Germany. Jacobi came from a Jewish family, but was given the French-style name Jacques Simon at birth. His father, Simon Jacobi, was a banker, and his family was prosperous. Carl was the second son in the family, the eldest being Moritz Jacobi, who eventually became a famous physicist. He had a sister, Teresa Jacobi, and a third brother, Edward Jacobi, who was younger than Carl. Edward did not pursue an academic career, but followed his father's profession as a banker. Jacobi's early education was provided by an uncle on his mother's side, and shortly before his 12th birthday, he entered the Potsdam Gymnasium. He had been well taught by his uncle and had remarkable talents, so in 1817, while still in his first year of school, he was placed in the senior class. This meant that by the end of the 1816-17 school year, he was still only 12 years old, but he had already met the standard required for university entrance. The University of Berlin, however, did not accept students under 16, so Jacobi had to remain in the same class at the Potsdam Gymnasium until the spring of 1821. Jacobi, of course, continued his academic studies despite remaining in the same class at school. He received the highest honors in Latin, Greek, and history, but it was his study of mathematics that took him the furthest. By the time Jacobi left school, he had already read advanced mathematical texts such as Euler's Introductio in Analysin Infinitorum, and was carrying out research on his own, attempting to solve quintic equations by radicals.
Jacobi entered the University of Berlin in 1821, still unsure of which subject to focus on. He attended courses in philosophy, classics, and mathematics for 2 years before realizing he needed to make a definitive decision between these disciplines. He chose mathematics, but this did not mean he could attend high-level mathematics courses, as the standard of university mathematics education in Germany at that time was quite poor. As he had done at the gymnasium, Jacobi had to study on his own, reading the works of Lagrange and other important mathematicians. By the end of the 1823-24 academic year, Jacobi had passed the necessary examinations to teach mathematics, Greek, and Latin in secondary schools. Of course, one might expect that he would have trouble obtaining a teaching position, since, as noted at the beginning of this article, he was Jewish. His brilliance seems to have been sufficient to overcome this obstacle, as in 1825 he was offered a teaching position at the Joachimsthal's Gymnasium, one of Berlin's leading schools. He had submitted his doctoral dissertation to the University of Berlin even before receiving the professorship offer, and was allowed to work quickly on his habilitation thesis. Jacobi submitted a paper on iterated functions to the Berlin Academy of Sciences in 1825. However, the reviewers did not consider the results worthy of publication, and indeed, the paper was not published by the Berlin Academy. The paper was eventually published, as it was published in 1961 with a commentary by K.R. Biermann.
Biermann, author of an unpublished early work of Carl Gustav Jacob Jacobi on repeated functions, 1961, cites the opinions of the original reviewers and vehemently criticizes them. While this was not the best start for the young Jacobi, it did not deter him for long, and his publication record in the following years would be notable for both the quantity and quality of his works. Around 1825, Jacobi abandoned his Jewish faith to convert to Christianity, which allowed him to teach at the university. In the academic year 1825-26, he taught at the University of Berlin. However, prospects in Berlin were not good, so, after consulting with colleagues, Jacobi moved to the University of Königsberg, where he arrived in May 1826. There, he joined Franz Neumann, who had also received his doctorate in Berlin in 1825, and Bessel, who was professor of astronomy at Königsberg. Jacobi had already made major discoveries in number theory before arriving in Königsberg. He then wrote to Gauss to tell him about the results on cubic residues he had obtained, having been inspired by Gauss's results on quadratic and biquadratic residues. Gauss was impressed, so much so that he wrote to Bessel to obtain more information about the young Jacobi. But Jacobi also had remarkable new ideas about elliptic functions, as Abel did quite independently and almost simultaneously. On August 5, 1827, Jacobi wrote to Legendre, who was the leading expert on the subject.
Legendre immediately realized that Jacobi had made fundamental advances in his favorite topic. Legendre reacted extremely well to the realization that his position as the leading expert on elliptic functions had changed overnight, with the new theory being developed not only by Jacobi, but also by Abel. Jacobi's promotion to associate professor on December 28, 1827, was largely due to Legendre's praise of him. In a letter to Jacobi on February 9, 1828, Legendre wrote, "It is with great satisfaction that I see two young mathematicians like you and Abel cultivating so successfully a branch of analysis that has for so long been my favorite subject of study, but which has not been as well received in my country as it deserves. With your works, you place yourselves among the best analysts of our era." In 1829, Jacobi met Legendre and other French mathematicians, such as Fourier and Poisson, during a summer vacation in Paris. During his trip to Paris, he visited Gauss in Göttingen. Jacobi's fundamental work on the theory of elliptic functions, which so impressed Legendre, was based on four theta functions. His article, Fundamental Nova Theoria Functionum Ellipticarum, published in 1829, along with its subsequent supplements, made fundamental contributions to the theory of elliptic functions. However, despite Jacobi's brilliant contributions to elliptic functions, he did not have the field to himself. As noted above, Abel was also making fundamental contributions, and to some extent, a competition had developed between the two. Legendre expressed this clearly in a letter he wrote to Jacobi in early 1829.
You proceed so rapidly, gentlemen, in all these wonderful speculations that it is almost impossible to keep up, especially for an old man. I congratulate myself on having lived long enough to witness these magnificent competitions between two equally strong young athletes, who direct their efforts to the benefit of science, whose boundaries they are increasingly expanding. A few weeks after Legendre wrote this letter, Abel died. On September 11, 1831, Jacobi married Marie Schwink, and a few months later, In May 1832, he was promoted to full professor after undergoing a 4-hour disputation in Latin. Jacobi's reputation as an excellent teacher attracted many students. He introduced the seminar method to teach students the latest advances in mathematics. Jacobi had a profound impact on these students and everyone else around him. Jacobi's strong personality and overwhelming enthusiasm were such that none of his talented students could escape his spell. They were drawn into his sphere of thought and soon represented a school. C. W. Borchardt, E. Heine, L. O. Hesse, F. J. Rickelot, J. Rosenhahn, and P. L. von Seidel belonged to this circle. They contributed greatly to the dissemination not only of Jacobi's mathematical creations, but also of the new research-oriented approach to university teaching. The trio of Bessel, Jacobi, and Franz Neumann thus became the nucleus of a renaissance in mathematics at German universities.
In 1833, Jacobi's older brother, Moritz, joined him in Königsberg, where he established himself as an architect. During the 2 years Moritz spent there, he became more interested in physics and left Königsberg in 1835, when he was appointed to the chair of civil engineering in Dorpat. In 1834, Jacobi received some work from Kummer, who at the time was a teacher at a gymnasium in Liegnitz. Jacobi immediately recognized Kummer's mathematical talents. Kummer had made advances beyond what Jacobi had achieved in third-order differential equations, and he wrote to his brother Moritz in 1836, describing how Kummer had managed to solve problems that had previously defeated him. In 1834, Jacobi proved that if a single-valued function of one variable is doubly periodic, then the ratio of the periods is non-real. This result motivated much further work in this area, particularly by Liouville and Cauchy. Jacobi conducted important research on first-order partial differential equations and applied them to the differential equations of dynamics. He also worked with determinants and studied the functional determinant, now called the Jacobian. Jacobi was not the first to study the functional determinant that now bears his name. It first appears in an 1815 paper by Cauchy. However, Jacobi wrote a lengthy memoir, De Determinantibus Functionalibus, in 1841, dedicated to this determinant. He proved, among many other things, that if a set of n functions and n variables are functionally related, then the Jacobian is identically zero, while if the functions are independent, the Jacobian cannot be identically zero. J. McCleary, On Jacobi's Remarkable Curve Theorem, describes one of Jacobi's most impressive results. One of the most beautiful results in the global theory of curves is a theorem of Jacobi 1842. The spherical image of the normal directions along a closed differentiable curve in space divides the unit sphere into regions of equal area. The statement of this theorem is an afterthought to a paper in which Jacobi responds to Thomas Clausen's correction of an earlier paper by Jacobi 1836. In July 1842, Jacobi and Bessel attended the meeting of the British Association for the Advancement of Science in Manchester as Prussian representatives. Jacobi's wife accompanied the two mathematicians. They returned to Königsberg via Paris, where Jacobi taught at the Académie des Sciences. The following year, Jacobi fell ill and was diagnosed with diabetes. His doctor advised him to spend time in Italy, where the climate would help him recover. However, Jacobi was not a wealthy man, and Dirichlet, after visiting Jacobi and learning of his plight, wrote to Alexander von Humboldt asking him to help him obtain some financial assistance for Jacobi from Friedrich Wilhelm IV.
We should digress briefly to explain why Jacobi was not a wealthy man despite having inherited a small fortune from his wealthy father. A severe business depression throughout Prussia, in fact it was a Europe-wide depression, led to a bankruptcy in which Jacobi lost all his money. Let us now return to Dirichlet and Alexander von Humboldt's attempts to help garner support for Jacobi's trip to Italy. Jacobi corresponded frequently with Alexander von Humboldt. The correspondence began in 1828, but it was not until 1839 that they corresponded regularly, and the 44 surviving letters between the two men make for fascinating reading. Dirichlet's petition to Friedrich Wilhelm IV, strongly supported by Alexander von Humboldt, was successful, and Jacobi received a grant that allowed him to spend time in Italy. He set off for Italy with Borchardt and Dirichlet, and after stopping in several cities and attending a mathematical meeting in Lucca, they arrived in Rome on November 16, 1843. Schleffli and Steiner were also with them, with Schleffli acting as their interpreter. The climate in Italy did indeed help Jacobi recover, and he began publishing again, though his health had prevented him from working for some time before that. Indeed, Jacobi's interests in mathematics were very broad, and, while in Rome, he took the opportunity to indulge his interest in the history of mathematics by working on manuscripts of Diophantus's Arithmetica, which were kept in the Vatican. Although his health had improved, it was felt that the climate in Königsberg was too extreme for him to return there. So a dispensation was obtained from Friedrich Wilhelm IV to allow his transfer to Berlin. He received a supplement to his salary to help offset the higher costs of living in Berlin and also to assist with his medical expenses. He was in Berlin by June 1844, and although his health prevented him from lecturing frequently, he did teach at the University of Berlin. In Jacobi's Critique of Lagrange, the changing role of mathematics in the foundations of classical mechanics, a course of lectures he gave in 1847-48 is discussed by H. Pulte. Jacobi, in his lectures on analytical mechanics, Berlin 1847-48, presented a detailed and critical discussion of Lagrange's mechanics.
Lagrange's view that mechanics could be considered an axiomatic deductive science constitutes the core of Jacobi's critique and is rejected on both mathematical and philosophical grounds. Jacobi's critique is motivated by a changed assessment of the role of mathematics in the empirical sciences. In After 150 Years, Jacobi's News on Lagrange's Analytical Mechanics, Pulte shows that Jacobi only came to hold these views on analytical mechanics later in his life, having previously ignored the physical interpretation of mechanics in favor of a purely axiomatic and mathematical approach. In 1848, conditions were bad in the German Confederation. Unemployment and crop failures led to discontent and unrest. The news that Louis-Philippe had been deposed by a revolt in Paris in February 1848 led to revolutions in many states and fighting in Berlin. Republican and socialist sentiments meant the monarchy was in trouble. Jacobi delivered a political speech at the Constitutional Club in Berlin that managed to upset both monarchists and republicans. As a result, Jacobi's request to be allowed to join the staff of the University of Berlin was rejected by the Prussian government. By the summer of 1849, the revolution was completely defeated. The Prussian government, still resentful of Jacobi, withdrew the supplement to his salary that allowed him to live in Berlin. He had to move and chose the small town of Gotha. He lived there with his family and a few months later accepted a position at the University of Vienna. The Prussian government suddenly realized what it would lose if it forced Jacobi to leave Prussia, so they made concessions that meant Jacobi could teach at the University of Berlin while his family remained in Gotha. It wasn't a good deal for Jacobi, and the fact that he accepted it indicates that he was deeply attached to his homeland. Jacobi planned to spend his university vacation with his family and spent the summer of 1850 with them in Gotha. In January 1851, he contracted influenza, then contracted smallpox before regaining his strength. He died a few days later from contracting smallpox. C.J. Scriba compares Jacobi with Euler. Jacobi and Euler were kindred spirits in the way they created their mathematics. Both were prolific writers and even more prolific calculators. Both drew vast knowledge from a vast body of algorithmic work. Both worked in many fields of mathematics. Euler, in this respect, far surpassed Jacobi. And both could, at any given moment, draw from the vast arsenal of mathematical methods precisely the weapons that promised the best results in attacking a given problem. Carl Gustav Jacob Jacobi showed us that even in the darkness of a lonely study, the human mind can glimpse entire universes. His life is proof that powerful ideas transcend time and place, that an equation can outlive its author. If this video touched you, subscribe now and activate the bell. You won't want to miss the next profiles of mathematicians who shaped our world. Leave a comment. Which of Jacobi's discoveries impressed you the most? Share it with friends who love science, and together we'll discover the legacy of unseen mathematical geniuses. Until the next video, where the next brilliant mind will reveal itself.